Hi, welcome to the online lecture series for the course 8051 microcontroller. In the last lectures, we have seen all the data transfer instructions. Today, we shall start with the arithmetic instructions. So, in this video, I shall be discussing two instructions. One is add, the other is add with carry. Before I start with the arithmetic instructions, few points to be noted. The first is, in most of the arithmetic instructions, accumulator is always the destination. The second point is, in most of the arithmetic instructions, all the conditional flags, that is the carry, auxiliary carry, parity, and overflow flag are effective. It may not be true for all the arithmetic instructions, but for most of the instructions, it is true. All the arithmetic instructions are executed by the arithmetic and logical unit, which we have discussed while discussing the architecture of 8051 microcontroller. So with these notes, we shall start with the first instruction, that is the add instruction. The syntax of the add instruction is add a source byte. As you can see, accumulator is always the destination. What does this instruction do? This instruction adds the contents of the source byte with the contents of the accumulator, and the result is stored back in accumulator. The destination is always the accumulator. All the conditional flags are affected. The source byte can be immediate data, a register, or a memory. Some of the examples I have written here. Add a hash 30h. You can see here the source is immediate data. So this is an example of immediate addressing mode. What happens here? The data 30h is added with the contents of accumulator, and the result is again stored back in accumulator. Second example, add a R2. The contents of register R2 are added with the contents of accumulator, and the result is stored back in accumulator. Remember, these braces indicates the contents of. The third example, add a at the rate of R0. This is an example of register indirect addressing mode. In this case, the contents of a RAM location pointed by register R0, it is added with the contents of the accumulator, and the result is stored back in accumulator. Now remember, here I have shown the braces twice because this is for an indirect addressing mode. What is the meaning of it? R0 contains the RAM location. From that RAM location, we get the actual data from the memory. The last example is an example for a direct addressing mode. Here the contents of RAM address 40H are added with the contents of accumulator, and the result is stored back in accumulator. As an illustration, I have taken an example. FFH is moved to A, 28H is moved to R2. So once you add, you get the result of 27. Now since the result is greater than 8 bit, okay, that's why you have got carry flag is equal to 1. So the total result is 127H, and accordingly other flags will be affected. So you can use your Kyle IDE. You can type this program and you can understand this instruction better. The second instruction to be discussed is a variant of the previous instruction, which stands for add with carry. I think there is a mistake here. It should be ADC. Let me confirm this for you. It is correct. It is ADDC. Okay. Now, this stands for addition, but along with the carry bit. Okay. In this case, the contents of the source byte are added to the contents of the accumulator along with the carry bit, and the result is stored back again in the accumulator. As usual, all the conditional flags are affected. This carry bit is added to the LSB position. Okay, I shall show you with the illustration. So in this illustration, I have set the carry flag. Set bit C, it makes carry flag is equal to 1, and I have moved FFH into accumulator, 28H into register R2. Then I have done add with carry A, R2. Let us see how this works. Okay, so I'll copy this. I will tell you in detail. Okay, so what you have in accumulator? In accumulator, you have FFH. So FFH means 1, 1, 1, 1, 1. Then you have 28H. The contents of R2. So it is 28H 0, 0, 1, 0, then 1, 0, 0, 0. Then you have this carry flag. Now, where is the carry flag added? The carry flag is added at the LSB position. Okay, now in our case, we have set this carry flag. So this will be equal to 1. Okay, so when you add this, so 1 plus 1 is 0, then again 1 plus 1 is 0, then 1 plus 1 is 0, then again you have a carry, but here we'll get 1, then again 1 plus 1 will be 0, so here it will be 1, then 1 plus 1 will be 0, again 1 plus 1 will be 0, and you will get a carry of 1. So your entire result is this. Okay, let me go through again. 1 plus 1 is 0, you have got a carry 1, again 1 plus 1 is 0, carry 1, 1 plus 1 0, carry 1, so 1 plus 1 plus 1 is 1, carry 1, so 1 plus 1 is 0, carry 1, 1 plus 1 plus 1 is 1 and carry is 1, so 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1. So how much is this? So this is 28, so it is 128H. Okay, you can check this in the Kyle software. So I hope you understood these two instructions. Okay, there is a major application of these two instructions. Okay, when we are adding a series of numbers in an array, we use add instruction, and when we have multi-byte addition, we use this instruction, that is add with carry. Okay, so in the laboratory programs, both the programs are included. So there the programs will be explained in detail and you will understand. Okay, so the other instructions will be discussed in the further lectures. Thank you.